by now our synthesizer should be starting to take shape. So far we've looked at making oscillators to generate rich and complex waveforms. We've looked at filters for sculpting our signal. We've looked at LFOs for controlling and fluctuating various parameters of the synthesizer, and we've looked at creating envelopes in order to shape notes for our synthesizer. So at this point you should be able to connect all of these elements together and have a simple working basic synthesizer. But today I want to look at adding some more dimensions to the synthesizer. Specifically, I want to look at depth and width. We're going to look at adding effects, so a simple delay line, and playing around with some stereo panning for our synthesizer. So what I've got here is basically a little custom metronome, and it uses the same principles that we've been looking at so far to build our synthesizer. So you'll see here I've got an oscillator, which is just a sine wave playing a simple tone of 110 Hertz, and that's going to an amplifier, so it's just going to play a continuous tone, but the amplifier is being controlled by a really simple envelope. Okay, so I just have this little metronome, so when I turn that on and I turn up my gain, we just have this really simple envelope kind of striking and opening and closing the amplifier to create this idea of a note. Okay, so this is going to be our really simple patch to demonstrate the kind of basics of delay in Max. Okay, so you could use you could create this patch to play around with, or you could use your synthesizer or whatever. Another helpful tool sometimes is you can just drag in sample audio. So I could just drag in here, this jongly track is kind of like the amen break, so you can just have that playing and hook that up to your amplifier, and let's just show you. It's being controlled by the amplifier, but if I hook this up here, there we go. So if you just want some quick audio, you could hook up something like that, but for the time being I'm going to use this. Now what we're going to try and do is we're going to try and delay this metronome. And actually, where we want to be doing that is here, at this stage, after the amplifier. So we've got our note. The note is opening and closing, and we want to delay that signal. So what I'm actually going to do is I'm going to create a subpatch for our delay. Now the way that we do that in Max is I create a new object, and I start with the object name P. So that creates a subpatch within a patch. And then I'm just going to call this delay. Okay, and what that's going to do is that's instantly going to create a new little subpatch here that sits within this. So this is where we're going to be building our delay. Okay, so one thing that we could do, if I just move this over here so you can see both of them, I'm going to put the grid on just so we can see everything and zoom in a bit. This is going to need some inlets and outlets before we can do anything. So I'm going to create a new inlet, and you should see as I do this, it creates an inlet in the main sort of subpatch folder. And then I'll do the same, I'll create an outlet here. And now if I come back to our main patch, we've got an inlet and an outlet, so I can connect those up. Now you'll notice now that our audio has stopped because our subpatch is not connected. So if I wanted to kind of bridge the circuit, so to speak, I could just connect those up again, and our signal starts. But for the time being, this is going to work for us. So where do we start with a delay? Well, first of all, we have to kind of think about what a delay is and how it functions, and how we can then kind of incorporate that and work that into Max. So what is a delay? Okay, to get started with delays in Max, I'm actually just going to create a new patch, because one of the ways that I want to explain this is not necessarily how we're going to use it in our subpatch that we just created, but we're just going to start fresh. So a delay system is essentially a way of taking audio in, a signal in, holding onto it, delaying or deferring it, and then playing it back at a specified delay time. Okay. So how does that work? Well, okay, what we need to do is we need to create a buffer. so something to hold temporarily our audio as it comes in. So we're going to create a buffer for our delay, and then we're going to say, okay, wait a second, and then play that back. Okay, so what we need to do is we need to create a special kind of buffer, which is a buffer that constantly records the most recent X duration. So in Max, that object is called tap in. Okay, and that's going to create a delay line. So a delay line is this special kind of buffer that's the most recent amount of time in that we can then delay or defer or hold on to and then play back out. So what we're going to do, we're going to create a tap in object, and we have to specify a maximum delay number. So the size of the buffer that we want to store audio in. So we're just going to start with a 1 second delay, which is 1000 milliseconds. Okay. So we create this tap in object. So now what we've got, if I were to take this easy ADC, which is going to record the audio from my microphone in. So now this object is constantly being filled with the last 1000 milliseconds of my voice speaking into the microphone. But what we need to do now is we need to access that. We need to play that back at a certain delay period. So to give you an example, let's just say easy DAC. Here's our audio output. So here you should be able to hear my voice coming through straight away. Now, tap out is the object that we want to use to get the output from our delay line. Okay, and now we need to specify another number, which is the initial delay line. Now, for our purposes here, we're actually going to set that to the same as the tap in duration. But there are some reasons why you might want to have a different number, and we'll get to those in a little bit. So let's say we have our delay line buffer, the tap in object, set at 1000 milliseconds, and then we want to listen back 1000 milliseconds later. So if I connect this up, you should hear the last 1000 milliseconds of my voice. So what we can do is actually create multiple tap out objects, because we've got this whole buffer to work with. So I could say, this is getting strange. Also tap out at 500 milliseconds. So now we have the right channel outputting from this delay buffer at 500 milliseconds, and the left channel outputting a whole 1000 milliseconds, so a second later. Okay, this is getting a little bizarre for me to talk and have my voice coming back, so let's move back to our other patch. So now that we're back in our patch with our simple metronome and our delay sub patch, let's implement a really basic delay. Okay, so first thing we need is the tap in object. So we need to create our delay line buffer, and we're going to set the maximum delay time, which is going to say 1 second at the moment. Actually no, let's say 2, because we know our metronome is beating at 1 second, sorry. So let's set twice that. And then we need to create a tap out object to kind of access or output some signal from that delay line. So let's just put it at something short for the time being. Let's say 250 milliseconds, so a quarter of a second. So we're going to connect those two up, and then I just want to, just so we can hear something, I'm just going to disconnect this. Remember, that's our through line. So I'm going to connect this up. Now this doesn't sound like what we might expect a delay to sound like. In fact, actually it sounds exactly the same. Why would that be? Well, because I've got rid of the dry signal, we're only listening to the kind of wet, delayed, affected signal. And one of the things we normally associate with delay is something that you may have heard a little bit when I was speaking before, but that was actually a feedback issue with the microphone. But there's no feedback going on in this delay line. There's no echo. So what's happening is our signal is coming in, it's running through the delay line, it's being delayed by 250 milliseconds, and then it's being played back out. But there's no feedback. So it's not like if I say echo, 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 and we have repeats sort of slowly fading out. There's none of that. There's no feedback occurring. So for that to happen, we would have to send some of our delayed signal back into the start of our delay line, attenuate it slightly so that it dies away each time it goes back around the feedback delay line loop. So we can hear our delay more clearly if I connect up that dry signal. So what we should hear is just two very quick notes. So that's our dry signal and our delayed signal 250 milliseconds later. So let's have a think about this feedback line. How can we do this? Well, we could just run our delayed output back in, but that's going to cause feedback, okay, and the bad kind of squeaky feedback. So what we're going to do is we're going to attenuate this feedback loop. So we're going to do that with the trusty signal multiplier, and we're going to say we're going to divide it by 0.2. Okay, so we're going to cut our signal right down. Now a really helpful way of looking at this is we're going to use the meter object. Okay, so this is like a little VU meter. It's going to let us see the signal gain. So if I just plug it in here, this is the signal of our delay out. Now let's make a copy and listen to it when we've attenuated the signal. So you see how this one is quieter? We could make it really quiet just to show you. See, now it's barely lighting up on the VU meter. So we know we've got an attenuated signal. So what I could do now is I could take the output of this attenuated signal from the delay out and pass it back into the delay in. There we go. Now it's starting to sound more like a kind of familiar delay echo effect. We have that bum 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 bum. You hear as the note gets quieter. That's because each time it passes around that feedback loop, it's being attenuated, it's being turned down. So it goes back round, and then it goes back round, and it goes back round, and each time it dies away, it gets quieter because we're turning the volume down each time. Now, if I sum this with our dry signal, this should really begin to sound like a delay because we'll have that first hit and then we'll have the delay cycle. There we go, a really simple echo. So what else can we do with an echo? Well, here's the simple tap in, tap out object. Now what we could do, if you've seen kind of old analog tape echoes like the Roland Space Echo, you might have seen multi-head delays, which is basically where our signal is delayed a number of times with multiple taps. Now the tap out can do that. So what we'll do is, if I just get rid of our meter here, I'll just move this out of the way, and then I'll use the Command-Shift-Y shortcut to just clean things up. Tap out will actually let us add additional arguments for further delays. So I've got a delay here of 250 milliseconds. Now if I add a 500 millisecond one, so doubled up, then we wouldn't necessarily hear it particularly well because obviously it would fall on the next sort of beat, as it were. So actually what I'm going to do is I'm going to add one at 350 milliseconds. Now what we're going to get is we're going to get a tap out 250 milliseconds in the past and a tap out 350 milliseconds in the past. And that's going to come out of the right outlet. See here, it's just created an extra outlet for us. So what we could do, we could very quickly, if we wanted to hear that, we could just sum it to mono here so they both come out at the same one. Can you hear that? Ba-dum-dum, ba-dum-dum. But more interesting would be Well, if now we've got a stereo image, so let's create another outlet and let's send this out. So we've got our 250 millisecond delay coming out of the left outlet and the 350 millisecond delay coming out of the right outlet. And you'll see here that now I've got a second delay out. So here I've got a gain slider, and I'm just going to make a copy of that, and I'm going to send this signal here. Now, one thing when you're working with stereo is it's kind of nice if you don't have to worry about changing left and right separately. So if you look, you have to go quite close because otherwise these two outlets are very close together. But there's a slider value, so I can hook that up, and when I control the one on the left, it also controls the slider on the right. So I'm going to take this over here, and now I've got a stereo delay. So we have a mono in, a single channel in, so this is just summed straight down the middle. But now if you're listening on headphones, you'll have that delay playing in two ears. And this is taking us towards thinking of stereo space a little bit more in our synthesizer. Okay, so I just want to bring back the delay subpatch just to have a look again. So we've got that feedback. We've got 250 millisecond delay and a 350 millisecond delay. So what if we slowly bring up our feedback? Now, you don't want to take it over about 0.5, and you certainly don't ever want it to get close to 1, because if you do that, what's going to happen is you're not going to be attenuating anything on that delay line. So that's when you're going to get feedback, and that's when things are going to start sounding rather unpleasant. The most I would normally take this is sort of 4.5. So let's just take it right up, and now you should hear that delay really continue along. You might have just heard it there. There's a clip when you change things in a delay line. If you want to get rid of that, there's a helpful guide in one of the Max MSP delay tutorials that you can have a look at. But it's not too alarming, so I wouldn't worry about it too much. So we have a stereo delay, and it's just sort of bouncing along there. If I wanted to, I could also just take our, so if we think this is the wet signal, and the dry signal comes in as normal, straight from the source there. But what else can I do? Well, tap out will actually let me change the delay time, and I can do this with a signal. So I'm just going to change, if you see here, I'm going to change delay time 1, which is this tap out 250. Actually, for the time being, just while I do this, I'll get rid of that second tap out. So now, at the moment, this is set to 250 milliseconds. But I could set this much higher. And this is now coinciding with the metronome because it's set to 1000. So actually what you're hearing is the note, and then the next note and the previous note is being triggered at the same time on the delay. So actually let's just offset this slightly. Let's say 900. And there's that interference again as I drag the note, as I try and change the delay time. It's creating some interference. So if you want to avoid that, do look at that tutorial. So what else could we do with this simple delay? Well, I'm glad you asked. Remember our LFO and how we use that to control a frequency cutoff of filters? Well, let's play around with changing this delay time. Let's have a variable delay line instead of just a static number. So what I'm going to do is I'm going to go back to let's have another stereo delay. Just hook that up. And what I'm going to do is I'm going to create a sine wave. I'm going to set it very slow, and I will scale it. with the scale tilde object. So we know that it's coming from -1 up to a maximum of 1, and then we want out of that, we want something from, let's say, 100 milliseconds to, let's just keep it quite contained, let's say 200 milliseconds. So you'll see that the tap out object will accept a signal instead of just a float. So we could pass it a number like we were doing before, or we could send it. Now just so you can hear that, let's make it a bit more pronounced. So you hear that this effect becomes a lot more pronounced with a slightly faster cycle. And hear how the pitch of the delay line changes? That's because as we speed up and slow down that playback buffer, it's much like tape speed manipulation. Remember, if we slow down a tape, the pitch goes down, and if you speed it up, pitch goes up. This is the same process. So we could set this faster. It can get out of hand quite quickly, but if you set it to something more subtle, let's say 150, you can get some nice effects here. So maybe the cycle is too periodic. Remember there was that other object that we used when we were looking at LFOs, and that's the random object. So it's band limited random signals. So now our delay speed is just going to fluctuate. So it's not always going to go up and down in a smooth oscillating pattern. It's just going to move, and it'll sit there. And this can be really nice when you play around with it in context of a feedback loop. So you kind of just get this small fluctuation. Particularly with drones, if you have a kind of droney synthesizer, this can work really effectively because you end up with very small fluctuations in the delay time. And this is actually a lot like the way that phasing and chorus effects work, with a random input just fluctuating the delay line and causing it to vary ever so slightly. What happens if I bring this back up to something larger? And remember that we could do this in stereo as well. So I could have another one, and you notice that now they are slightly different numbers, and that could affect the delay time too. So now I have this really nice stereo effect where the left and right delays are sort of moving against each other ever so slightly, so we get this rhythmic phasing occurring, which is really, really nice. And again, it wouldn't be max if I didn't take it way too far. So let's take this right up to from 100 milliseconds up to 2000 milliseconds. So right up to 2 seconds, which is the maximum delay length. And we'll do the same thing here. Let's speed this up a bit. I could lose hours and hours of my life to this, and actually I have done. Okay, so you can see how we can kind of have a little bit of a play around with these delay effects. So even though it's a very, very simple implementation of an effect, there's a lot of fun to be had here and sort of trying things out. Remember, it's very easy to overdo effects, so you might want to start off keeping things subtle, and if you do get kind of if it does start to run away from you, think about, attenuating things, bringing things back, working with a smaller fluctuation. One thing to note as well is, like right now we are just listening to the delay line. So if I come back to our main patch, this is our delayed signal, I could also create another copy of this just for our dry signal. So this is just going to be direct from the amplifier, and I'm going to connect it up to our outputs. So in that case, it might be good to kind of just bring the delays down slightly. So I still have our main central mono signal. Then we have the delay in the sort of background. So it's not necessarily taking over everything. Okay, now let's have a little bit more of a think about stereo. Okay, so we want to have a little think about the stereo field and stereo panning in Max. So how things sit, where things position themselves in our stereo field, okay, left to right. Now, we could get really detailed and in-depth and talk about pan law and some of the kind of functions and mathematics of calculating panning and different ways of linear or logarithmic panning and stuff, but it's just not worth it for this project. Okay, what we want is a quick, simple pan mechanism, and thankfully for that, Max gives us one really nicely. It's just called Pan 2, and it's going to take care of everything. So there's our panner. Okay, we're going to take a mono signal in, and it's going to allow us to position it in the stereo field. Okay, we can pan it from left to right. Now, let's think about putting this into use. So I've got my simple metronome object here, and one thing that I've added is a really kind of attenuated, so quite quiet noise oscillator. Now the reason for that is having a kind of noise signal, something with a broad spectral band, it gives us, it's a lot easier to place that in the spectral field, as you'll hear, than a simple sine tone is. A sine tone is quite difficult to place in terms of stereo image. So actually, thinking of that, I'm going to change that. I'm going to make that a triangle wave. So we've got some harmonics to work with as well. So if I just turn this on, you will hear that we've got a little bit of noise mixed with a triangle wave. There we go. I've turned my delay down. My delay's still there, but doing its thing. But for the time being, we're just going to focus on this. This is our main signal, okay, straight from the amplifier, and gain control. So what we could do, let's just get rid of this for the time being, because we're thinking about stereo now. I'm going to connect the output of my gain slider, just so we've got a bit of control of it. I'm going to connect that to my pan device, my pan 2 object. And now we've got a left channel out and a right channel out, okay? And I'm just going to connect those directly to our output. So just by default, our signal is only coming out of the left output channel. So we need to find a way of controlling this. And if we look at the inlets of pan 2, you see that we've got two ways of controlling. We've got pan with -1 equals left and +1 equals right, and we've got one that's scaled to MIDI numbers, so 0 equals left and 127 equals right. So we could use either of these. For the time being, I'm just going to hook up to the MIDI one, and I'm going to say, let's just try this. So this should go from 0 is on the left and 127 is on the right. Let's see, hit enter. There we go. And so that would make 64 the middle. There we go. So if you're listening to this on headphones, you should hear that signal move as we go, and I can just drag this around as I want. So what could we do with this information? Well, first of all, I mean, we could just set up something like a dial to give us a little user interface control of this. So I could create a new dial object, and let's just set some limits on it. Oh, it's already set to 127, 128 as the maximum. So I can just drag this around and pan my sound if I want. Okay, that's relatively easy. What about if we do some more traditional Max programming here? What if we create a random panner? So every time one of these notes is triggered, we get a new position. That's quite nice. So we're just going to get different random stereo imaging each time. Or we could do the same thing that we did with the delay a minute ago. Think back to our LFO control, okay? Now for this, Midi panning's not great, just because we're going from 0 to 127 in integer numbers, so no decimal places. Whereas if we can go from -1 to 1, we can use those decimal places as a way of getting a smoother transition, a smoother movement. So actually what I want now is I want to hook up to a float number. I'm going to hook this up to the -1 to 1, and I'm going to set a limit. So I'm going to set a minimum number in the inspector to -1 and a maximum of 1. So same thing, I can just drag this around and get that. So we want to try our LFO control. So I'm going to do the same as before. I'm going to create a, I'll zoom in a bit, create a cycle, a slow cycle. So I'm going to give it a really low frequency, and then I'm going to hook it up via a snapshot. I'm going to say 10 here. Remember, we use snapshot to change from a signal into a number. Now I've just got a nice even pan. I can speed this up a bit. Now just to demonstrate this, I'm just going to get rid of the envelope a second. Set this to 1. And now you can hear that more evenly moving about. We could do this with the MIDI 0 to 127. We could just use the scale object, so we know we're going from -1 to 1, and we want to go from 0 to 127. So I could hook this up here, give ourselves another integer number. And see, we still have that moving. Another thing we could do, remember we don't have to just use a sine wave, we could also use a random fluctuation. So now we have a slower transition from one random number to another random number. So remember, we don't have individually cued random points, which we had before when we were hooked up to this metronome. We were moving from one random number straight to another random number. Now we're using the LFO to kind of oscillate between those values. So we're using the pan2 object to take a mono signal, okay, a single channel of audio, which is we're just going to hear is straight down the middle, and we can pan it from one speaker to another. So I'm going to get rid of my metronome thing now, and what I'm going to do is I'm going to build a bit more of a drone. So let's say a saw, let's do that a fifth above 165, hook that up, and give us another harmonic here. Maybe let's make this a saw an octave lower. But maybe just off an octave lower. Ooh, a bit loud. Okay. So why am I doing this? Right, well, what if we had this stereo image, but what if we had two stereo images that could cross? So we had a really wide kind of deep and rich stereo image here. So I'm going to get rid of this. So I'm just using this mono control here. I can get rid of this control as well. Oh, that doesn't want to be 2, that wants to be 0.2. And actually what I'm going to do is I'm going to split this. So I'm going to keep these two, the triangle and the noise, in one, and I'm going to put these other two in a different channel. So this could be a stereo image in and of itself. Let's just disconnect our delay for the moment. Maybe we'll come back to that in a bit. So I could have this channel hooked up to the left and this channel hooked up to the right. But what if both of them were panning? And what if they were panning relative to each other, so they were switching over? So I'm going to hook them out here. I'm going to start with this channel and we're going to hook it over to this. So you should hear this now just sweeping backwards and forwards from one channel to the other. Now I'm going to create another pan object, and the stereo output of that is also going to go straight to our output. And that's going to take our other signal. Okay, so let's call this our A signal and our B signal. There we go. Now, I don't want to just send it, I mean I could send it just a copy of this. I could send it at a different speed, maybe a little bit faster. Let's do it at 7. I could do this. That's kind of cool. So they're moving at different speeds, they're rhythmically phasing over each other and moving in the stereo image, so we're going to get some interesting fluctuations and patterns occurring there. But what if they were more symmetrical? So what I actually want to do is I want to send this pan object the reverse, the stereo mirror image of this one. So let's say this is signal A, so when signal A is over here, signal B is here, and they cross over like this in symmetry. Now to do that, I'm going to use the reverse inlet operator in Max. Okay, so this is the subtraction operator, so I'm subtracting from a number, but I'm reversing the inlets. So I'm going to say subtract this number coming in from 127. Okay, now let me just slow this down so that it's very clear and you'll be able to see what we're doing here. Okay, so watch this number. I'm going to pass it here. I'm going to say subtract this number from 127, so that this other number that we get out is going to be the mirror reflection. Okay, so just a case in point, I would just want to show you this, make it very clear. Ooh. While this number is set to 0, this is set to 127. And then when this left number is set, so signal A is set to 127, the other is 0. Okay? So now, signal A is panning in one direction, and signal B should be the mirror stereo image of that. So we have these two signals now sweeping backwards and forwards in symmetry, which is quite nice. This sawtooth is a little loud. Let's balance this out with a... There we go. Let's make a copy of our delay signal. So let's do stereo on stereo on stereo. Plug this over here. So now I'm routing my panning signals being panned here, and they're also getting hooked up to our weird delay from earlier. I really hope you're listening on headphones right now. So by taking the LFO speed up, we've created a kind of stereo panning tremolo unit. You just watch these constantly panning backwards and forwards. If you want to see this, remember that meter object that we used earlier. Let's just spin it over here. We could create a copy. So these are just going to move as it pans backwards and forwards. Okay, we've looked at creating a simple, if weird, delay with the tap in and tap out objects, and then looks at ways of controlling the delay time or controlling the feedback of the delay, so the number of repeats. And we've looked at using the pan to object for controlling some stereo panning of our synthesizer. Now there are hundreds of ways that you could choose to implement in this in your own synthesizer project, so I would encourage you to play around, do some strange things, have a little fun with it, and see what you get out of it. Enjoy!